Zach, thank you so much for the raid. I literally just like swapped over and actually got things started. That's good timing. Congrats on the first also. I hope your stream was good. I was peeking at it, but I was kind of off in my own world this morning. Rex hate? Fenbox hate? Your mastery of every situation will soon prove very important. That's a bold compliment. Your mastery of every situation. Just add 50 to the song number. I've had I'll turn the song up for a minute. I've had this song stuck in my head like all day yesterday, and it's Ed Sheeran, so I felt like it'd be appropriate for the stream if I played it. I am God. Hey, PhD. It's a good song. I'm gonna turn it back down though. That's the one I should karaoke. Oh, you know, that would be a good one to karaoke, Slim. That's true. Yeah, thinking out loud. I don't think I want to karaoke, but if I end up karaokeing by some twist of events like the last time I karaokeed with you, that'll be the song that I do. Okay, so plan for today, in the absence of questions from chat, which may or may not come, I really need to get familiar with little o and big O notation. And so that's what I want to spend today thinking about. I guess... I think it's... I don't think I want to draw right now. I just want to get started on talking about little o and big O, but maybe like a little later in the stream, sure. O of n log n. That's... Oh, I just bumped my mic. Sorry. That makes you think of a fast Fourier transform, which is awesome. So yeah, so we're learning the formal definition of little o and big O, and it really doesn't match up with how I've hardly seen little o used, but like it doesn't really match up with how I have seen big O notation. So the two contexts that I see big O notation in, or that I have seen big O notation in previously, is algorithm, I guess complexity. N log n. And then the other place that I see it is like with Taylor series. If you don't feel like writing out the terms past a certain point, instead of ... you can do just like O of whatever. So like you can like 1 plus x plus like x squared over 2 factorial plus O of x cubed. Do I need to know about big theta? So far we haven't talked about it. I don't know if we will need to know about it. I'm aware that it exists. I don't know anything else about it. Oh, it's like a lower bound. Are you sure it's not an upper bound? Have I seen big D? Depends which big D you're talking about. And so these are really like kind of like, I understand what these mean in context, but I don't understand how they match up with the actual definition of big O. How does this impact the court of Camelot? I don't know, F. I wish I could answer that question. Also, I guess maybe you shouldn't be out partying yet, but I hope you enjoy the party once it happens. Comes from circumference. Big O gives you an upper bound, big omega is a lower bound, big theta is both upper and lower. Ooh, okay. Yeah, and so there's a really weird distinction that was made in the lecture yesterday for the class this is attached to. We were talking about... Ugh. I'm looking at my notebook right now. We were talking about asymptotic expansions, which are defined via little o notation. But they're specifically not necessarily an approximation of your original function. And so I'm not quite sure what it... Like, they said instead it answers questions about leading order behavior of f and relative dominance, which I'm not exactly clear on what that actually means, but yeah, I don't know. This is a good song, yeah. So it's kind of confusing where it's like you're using it to get estimates, but they're not actually estimates or something. But let me put up the actual definitions of little o and big O. Big O. We say f equals big O of G, fog, as x goes to x naught, if I need to switch to type or to handwriting. If there exists a delta and a c, both greater than 0, such that the absolute value of f is less than or equal to some constant c times the absolute value of g, for all x in x minus x naught less than delta. So in some neighborhood of x naught. I don't know if this counts as numerical analysis. It's definitely used in numerical analysis. I think this is called asymptotic analysis. Which probably just has a lot of intersection with numerical analysis, but I bet it would be considered slightly different. Yeah, so in the class that I'm studying this for, we're going to use this with ordinary differential equations to apparently do something helpful. I don't have the... I mean, I don't have the song request stuff going right now. Okay, and then let's put up the little o. So little o is like a stronger condition, I believe. Like, it's harder to qualify for, but if you do, you can say more things. So we say f is little o of g as x goes to x naught if... Trying to avoid a Taylor Swift marathon again? I am, yeah. I'm scared. Especially if FA is lurking, you just know it's going to happen. There she is. Dude, my there exists really sucks. Okay, that's a slightly better one. Okay, if for all epsilon greater than 0, there exists a delta greater than 0, such that the absolute value of f of x is less than or equal to epsilon g of x again in some neighborhood of x naught defined by delta. And they were saying that this, like, there's some small technicality, but you could basically think of this statement as being equivalent, which is limit as x goes to x naught f of x over g of x equals 0. It's apparently not exactly the same statement, but it's like close enough that it's pretty good at intuition. So epsilon constant for g of x goes to 0. The epsilon. Yeah, like the point is that like, or like the interesting stuff happens when epsilon is very small, just like with epsilon delta limits. And so it's saying in some sense that f of x is way less than g of x because it has to be smaller even than some crazy small multiple of g of x. Whereas with big O, you just need to find any multiple, so. Let epsilon be less, yep. Okay, and so the first example they showed in class that I want to figure out for myself was show for all n greater than m that x to the n is big O of x to the m as x goes to 0. Another tricky thing is that little o and big O are defined around a point. But in the context that I've seen it before, they never talk about a particular point. So there's some implied point or set of points that like these must be around, I guess, but I don't really know. I guess this would be basically like for very large n. Then x kind of, that could vary. I don't know. Usual definition of the perfect case when x naught is infinity. Okay. So the first thing to realize is that, okay, so n is greater than m. So the reason the bigger power is smaller is because x is going to 0. If x is going to say like 2, you would have to flip these. Like I think maybe we should try and prove that case too, but let's start with 0. I wonder if you could show that. You could probably show this for little o also. That might be a good thing to try. So we just need to find a delta and a c. So let's just say that delta equals 1 because we need to start somewhere. Then we're concerned with the neighborhood around 0, which is like radius 1. And we want to show that x to the n is less than or equal to some constant times x to the m. Like, we basically need to find a c such that this is true. I would bet that c equals 1 works. Just intuitively. Oh my god, is this Britney Spears? No, it's not. Sorry, I was getting this song dreadfully mixed up. This is Maroon 5. Holy crap. Never mind. But we can't like just start with this statement. How do we like build towards it? I don't know. Let me look at my notes because this was an example problem. I guess if... Okay, so... Hey, Papadoria. Yeah, that's what I'm trying to study today until we get a question. I've got to know big O and little o notation for one of my classes, and I haven't really been able to wrap my head around it. So saying delta equals 1 gets us this statement, that the magnitude of x is less than 1. We could raise each side to the power of n minus m, which is a positive number. And that's still less than 1, because 1 to a positive power is still 1. Well, even 1 to a negative power is still 1. Remember, only ever using it to resolve nasty limits. We're apparently going to use this with ordinary differential equations. I don't know how yet. Well, also to evaluate integrals. Well, okay, wait. I think we're going to use these to evaluate integrals, and then those integrals we're going to use for ordinary differential equations. I only just completed the first week of classes, though, so we haven't actually tried to use this for anything yet. Hi, Clonk. Hope you're doing well. And then presumably we can just I may be doing overkill in the algebra here, but this is a positive number. We can just multiply it to the other side without upsetting the inequality. And so I think we've implicitly found that c equals 1. Okay. Ved. Yeah, sorry, I'm not able to stream as much because I've just got classes. So many things happen in your life? Like what? Hopefully good things. You have your JEE mains exams on 21st of January? Ooh, geez. Oh gosh, I just turned like Minnesotan there. Good luck with that, Ved. Holy crap, that's big. All those numbers? Yeah. Oh, you know, I forgot to actually check it. I don't think I went over, though. Can I check it quickly now? Because I did time it so that it would refresh a few days after I did my last IRL stream. I wonder if it'll tell me my data history. I can't find it. If they're, it's probably somewhere in this app. Like I'd have to find a previous, like where are my previous bills? I don't know. Yeah, I can't easily find it. Love is the triumph of horny over smart. I don't think that's true, but okay. Who am I to argue with the fortune cookie? My Wi-Fi is lagging so bad, everything is so delayed. No, Papadoria, I'm sorry. Okay, let's okay, so I want to try doing two other things with this. I want to try saying that's a great emote. Let's try doing the reverse if we're like going to 2. I just want any number that's greater than 1 is the important bit there. So we'll take delta equals 1 again. Then we have x minus 2 is less than 1. This will be slightly harder. I assume it would be a good idea to repeat the same process, though. Should we triangle inequality this bad boy first? That might be a good idea to triangle inequality this. So this is bounded. Ooh, that doesn't go the right way. We could reverse triangle inequality it. But that's making it worse, I think. Okay. Well, let's just go right for the throat here. And raise each side to the n minus m. And so we'll say x minus 2. Wait, what do we need again? Interesting. We need to get, like, these 2's are an issue. Because we need to arrive to x to the m less than or equal to c x to the n. And these 2's are really cramping my style. Oh, let me bring up what Papadoria just posted. This isn't asking for help. This is just showing an example of. These are the nasty integrals and asymptotic notation comes in handy. Minesweeper? Ooh, okay. We'll do that in a second. Well, I don't see any integrals on this page. These limits look terrible, though. I would hate to do any of these limits. Trig what face? I agree. I think Minesweeper more since seeing you speedrun them, nowhere close. Yeah, PhD. It's really bad because I'm the type of person like I need to always be doing something with my hands or else I go crazy. And so if I'm just like watching a stream or a movie or something, I'll just have Minesweeper up on my phone and just be tapping away at it. So I've gotten way too much practice at it. Yeah, this looks terrible, Papadoria. Not sure why YouTube. Yeah, I'm sorry about your Wi-Fi. Okay, let's do Minesweeper. No guessing. I think we've been doing mediums. Oh, what is this? There we go. I'm gonna try and take it slow. My mouse accuracy is not great. My brain accuracy is also not great, so there's not much I can do about that, though. Uh, Nearly there. Noish! Not bad. 42 seconds. Thank you for the redeem. You know, learned. Yeah, it's not like. Actually, let me bring another one up. Because like the rules aren't too hard. It can be like a lot to like work through, like what to do. But basically, like this one here just means that there's one mine somewhere in these squares right around it. So because it's on a corner here, you know there has to be a mine right there. Because that's the only one that's still like we don't know anything about. And that's kind of basically how you like work through these. Like this two here means that there's two bombs somewhere on those squares, but we don't know where yet. Or like this three means there's a three somewhere on these squares. Or there's three bombs somewhere in these squares, but we don't know exactly where yet. And that's basically like how you like work through it, but there could be some tricky situations. What is evil? Oh, I mean, that's not that bad. Um, I feel like that shouldn't be that hard, but it's kind of weird. I wonder if it's potentially not true. Oh wait, this might not be true. Um, Wait, well, okay, well, Desmos? How can I set this up? I guess we can just do x to the n, x to the m. We're looking at 2. And I'm saying n is larger than m. Oh yeah, this just isn't true. that's why I'm having a hard time with it. Wait, no, is it true? Wait, I'm looking. Oh wait, no, 2. But I think it might not be true for every. I mean, maybe it is. Huh. No, I changed my mind. I think it is true. As long as we're careful of x equals 1, we're good. Basically that for n greater than m, x to the m is less than or equal to x to the n at x equals 2, or in and around x equals 2. And so I'm pretty sure it's true. I'm trying to actually like prove this thing with big O notation, but it's kind of weird to work with these absolute values. I mean, we really care about like a neighborhood around X, I guess. So I wouldn't quite call it a constant, but like, like x to the n equals x to the m plus c for some value c. I mean, c would be n minus m. I'm not sure if that's like a useful statement, right? Or unless I'm misunderstanding like where you're going with that, but yeah, times, yeah. X to the c is greater than 0. Yeah. Well, I mean, yeah. Oh. Oh, well, yeah, it needs to be more than 1 with multiplication. Which we could still justify that since we're talking about a neighborhood around 2. I don't know, but I kind of need to like maybe there needs to be something more. So yeah, I guess well, I'm trying to learn like little o and big O notation because I've seen it used like in context before, but I haven't actually learned like the math behind this, and it kind of it doesn't really match up. Or I'm trying to figure out how the actual math definitions here match up with like how I've seen it in context. And so I'm just trying to spend some time with these like math definitions to understand them first. Yeah, it's not really talked about as much, Peach Tea. There's other notations too that Slim and Zach were mentioning, like big omega, well, I guess big theta would be capital theta, maybe. But yeah, there's a couple of notations to talk about the asymptotic behavior of functions in different ways. But yeah, I think to prove something is big O, we can start with either delta or with C. If we start with delta, we have to start with this statement and work our way towards this statement. And if we start with C, we do the reverse, like starting with that and going to that. So if I stick with my thing of starting with delta, we start here and we want to end up here, ideally with an actual value for C. Well, we have to have an actual value for C. Or prove that it exists somehow. The thing that's messing me up is the -2. Do I learn big notation when evaluating efficiency? Yeah, exactly. Like same. And I understand when it's used in that context where like different sorting algorithms take more and more time depending on the algorithm. It's kind of weird in just like the strictly math sense though. Why didn't I do TI? What is TI? It might help, yeah. Let's see. Oh, so the regular triangle inequality. Actually, let me keep that there. The regular triangle inequality would give us this. But this inequality doesn't go the right direction. Like this inequality doesn't help me anything with this inequality here. We need something that's smaller than the absolute value of x minus 2. So there is the reverse triangle inequality. But then these outer absolute value bars, I don't quite know what to do with those. Yeah, let's look at what Jed posted. Right. That's a neat property. Makes sense. Hmm. Yeah, no, I guess it's like the actual like proof part that I was trying to do. This one also, or the book for the class also kind of gives a similar discussion as that. I don't know, maybe it's not worth worrying about this particular example. It is kind of like it shouldn't be that hard though, I feel like. I think somehow bringing those n's and m's inside the absolute value can help. So I'd imagine you'd have to do some kind of 2n over 2m. 2n or 2m. Maybe I mean I was almost wondering about like binomial expansion, but that feels really like too much. uh but yeah, we could definitely validly do this. And we could do that at an earlier stage too. If we cared to. Binomial expansion, you say? I'm trying to avoid it. Oh, you are going with the binomial expansion. Okay. Um, hmm. I'm not sure there would be cancellations because I'm just like thinking about like the constant term here will be minus 2 to the n. The constant term here will be minus 2 to the m. And those definitely won't cancel because we know that n and m are never the same. It's not a bad thought. I'm not sure if it works though. Even then, we have to deal with the absolute values also. Well, I mean, we could just try the other direction. Like, what if we say c equals 1? That means we can start with the statement x to the n is less than or equal to x to the m. And then we need to build our way. Do I have this reversed? I think I do. I do. And we need to build our way to the statement x minus 2 is less than some number delta. We need to find that delta. I was just thinking this is a pretty good song. It's Elton John. Okay. I don't think I've heard this one. It's called Your Song. Oh, wait, the music might be a little bit loud. Sorry about that. Let me turn it down a teensy bit. Oh, that's a better spot. So I know that Don factorial is Don times Don minus 1 times Don minus 2 times Don minus 3 times 1, but who is Don minus 1? It's a good question. I'm most thinking about like ancestry, like maybe my dad? I don't know. Must be an imposter? Yeah, or maybe that. Hope you're doing well, Mega. Technically alive, you know? Sometimes that you just got to be grateful for that, I guess. Well, okay, can I... Oh, wait. Are you guys waiting? I don't think you're waiting. What if I take the n minus m root of each side? Wait. Never mind. No. Sorry, that's going backwards. Never mind. Stop waiting. I'm trying to, like... Yeah, I would like to deal with this too before I bring in powers. Oh wait, we should be able to do that. That's something we were doing in, like, Zach's analysis class. Like, can we say... because if x minus 2 is less than 1... we're dealing with this interval here. Can we also say that the absolute value of x is less than 3? That's also a true statement we could say. Maybe? Yes? Specifically because delta equals 1? I don't know. I don't know if that's... I think... Oh my god. How are we doing this in... I think it needs to be a trick like that. Does Zach still have the things posted? Oh, I think he does. Let me see. I'm going back through our notes. There was a whole day where we were working with any, like, messing with inequalities. And I want to see if I can find it. Ooh. No, I don't think that's it. I think I might be getting closer, though. Yes. Copy link. I'm really glad that we saved these images. So shout out Zach. When was this? How do I read this date? Wait, meeting 9, 24 Jan 30. So 2024 January 30th? He taught a real analysis class live on Twitch. He's taught multiple real analysis classes on Twitch, but this particular one, I guess, happened in early 2024. And this is probably me and Obi who worked on these questions. That class is like the Zach's analysis classes are still really helping me. Like we've been talking about like uniform convergence and pointwise convergence, and actually it's come up in a few of my classes, and already knowing what those are has been so good. Pen, yeah, same. I have it right here. Oh, fuck, I almost dropped it. It fell in its frame because I dropped it. But I do still have mine. I saw the stuff that you sent me a long time ago too for the seal of approval. Yeah. For when you did like the QED giveaways, and I have like I have a pie-shaped cookie cutter, a pie-shaped ice cube tray, and that like prime number pencil. Aditya, why are you scared? Those are like spread around my apartment though. GA exam in 9 days. Oh, geez. Good frickin' luck, Aditya. I hope you do well. Okay, so in this question, we know the absolute value of x minus 4 is less than 1. And so if we want to say something about the absolute value of x minus 3, surely like 2 and higher would work, right? Oh my god, this is hard to scroll around with. Yes. I don't know, Adia. I do not know. Okay, yeah, so I think what I said is maybe legit. If we know the absolute value of x minus 2 is less than 1, then we also know the absolute value of x is less than 3. Good night, Aditya. Good luck. Just try and get sleep and take care of yourself. It's the best thing you can do. Now is this okay? So next question: how is this helpful? Oh wait, yeah, okay, no, this is great, right? Because now we do this. N minus m is a positive number, so this is fine. I guess we also need to care that the bases are positive, and they both are. Okay, I think we're in business. Because this bad boy is a constant. I think we've done it. Wait. Did I mix up my N's and my M's? Oops, I mixed something up here. N is more than M. So, oh, wait. Crap. I needed the reverse. Uh, how does that even work? Time for some O. Ooh. What was? How big is my O? It feels very small right now. I don't feel very good with big O's. Are you already done Final Fantasy-ing? I hope it went well. Let's make dinner then pass out. Fair enough. That sounds like a great time, actually. You're gonna grill in the snow. Ooh. What are you grilling? This is so annoying. If you ask me to make a big O face. It's burger night. Hell yeah. Borgor. Never confused about asymptotics. I do appreciate some nice asymptotics. Okay, well, do I need my inequality to go the other direction then? But, let's just erase this. Can I say instead of being less than 3, can I be more than 1? I don't know if I'm cooking or if I'm whatever the opposite of cooking is. But this would give me what I want. Ta-da! I think 1 should work. Like, x equals 2. Like, this is the line that we care about. And I think no matter what I do with n and m here, like, a constant of 1 is fine. Oh, I shouldn't do fractional powers. Ooh. Yeah, I think it's fine. Spaghetti, hello, welcome in. Peach tea, that's a good emote. Should call them butt imtotics from now on, or bootimtotics. I'm in favor. Limit to infinity. Love it, yeah. Bootimtotics. Hey, simply the goat. Nothing much. How about you? Okay. Yeah, I do love a good butt joke. Oh, you're Najaf. Okay, nice. I do remember you. come here for butt jokes mostly. I don't blame you. Okay, I don't know if this is a true. I mean, okay, let me see if we do this as an example in our notes. Did we do any little o examples, or do we only appreciate big O's around here? Okay, I don't see any little o examples, but I am curious if, like, can we say... Ugh, I don't know how to spell the word is. What is the definition of is? Is it... Oh my god. Is it true that... for all n greater than m, that x to the n is small o of x to the m. Okay, Mega caught my reference. Thank you. As x goes to 0 specifically. Because the higher power should be smaller than the lower power as x goes to 0. Okay, yeah. Am I a materialist? My first thought was what Mecca said. Is that like a philosophy term? Because I'm thinking of like just someone who only appreciates material things. Materialist. It's also a rom-com. Is that Pedro Pascal? It is. Okay, this is probably what Fringe is talking about. Materialism, idealism, Buddhism. Appreciate material science? Oh yeah, that's true. And hey, Eldritch, cheer this man. Hell yeah. Hope you're doing well, Eldritch. Okay. Materialism is a form of monism, holding that matter is the fundamental substance of nature, so that all things, including mind and consciousness, arise from material interactions and depend on physical processes, including those of the human brain and nervous system. Contrast with monistic idealism, which treats consciousness as fundamental and is related to naturalism, the view that only natural laws and forces operate in the universe. Into physicalism, the view that all that exists is ultimately physical. I was wondering if you're gonna pop up for the Pedro Pascal mention. Apparently, he just starred in a movie called Materialism, FA. I have not, or sorry, Materialists. So that's where he came up. Yeah, materialism, the philosophy. Okay, like the weird thing with philosophy is that like once you accept a viewpoint like this, there's gonna be some weird consequence of it. But like, I think as someone who hasn't thought that much about stuff like this, that's at least pretty close to how I think of the world. Like, physicalism maybe sounds even closer to how I think about the world. But I don't really know. I couldn't tell you the difference between physicalism and materialism, I guess. but if it's not exactly what I think, it's pretty close to what I think, I guess. So you need to kill 10 minutes. Oh, you did watch, I guess, because of a Pedro Pascal, probably. You're leaving in 10 minutes? Ooh, okay. Matter is emergent of the self. You gave up physics for philosophy? Interesting. I assume you know about like the philosophy niche on Twitch, like Ivan. Just in case you don't, I'll throw him a shout out though, because Ivan's stream is really awesome. Do you believe in quantum mechanics isn't the wave function fundamental? Matter is an emergent property of quantum fields. Oh, maybe Mega, yeah. I think you read somewhere that physicalism is a more refined version of materialism. Okay. You weren't good at physics, but you don't have to be? Oh, yeah, for like the metaphysics stuff. You got hijacked by a philosophy major? That happens. I don't mind it. I did a math philosophy stream a few weeks ago. It came later to plug some logical holes. Okay. But yeah, like I don't know enough about philosophy to really like say I'm definitely like one thing or the other. Because like whenever you accept one like premise like physicalism, there's always some issue that you can find later on if you keep following that logic that you have to like deal with. But as someone who hasn't done that, I feel kind of like a physicalist. Oh wait, okay, I should have read this next sentence that answers my exact question. Physicalism extends materialism by including forms of physicality beyond ordinary matter. Space-time, energy, forces, exotic matter. Some use the term interchangeably. All right, good luck, FA. Enjoy yourself. Have fun. Not a philosophy major yet? Haven't decided yet? Okay. Almost matter in philosophy. You got more than enough of it. I think it's good to think philosophically about things, but having philosophy is often absurd and self-indulgent. Yeah. There's definitely like I don't think philosophers really care about the question of why should I care about it. That's not like why they're there. It does seem kind of like just an exercise in like logic, I guess. I don't know. In like rational thinking. The take on philosophy is to not be any kind of ist, but to treat them like fun little thought spaces and see where they lead, like with math. Yeah, that's a nice like attitude for it. Self-indulgence is an illusion. Self-indulgence is the ego. It's only part of the body. Ooh, okay. Bam. Presuming they forced Socrates to drink hemlock. Oh, yeah, I mean, Socrates was famously like super annoying though. Like that was his method, the Socratic method. I didn't know. Like, I assume that's how he died. Yeah. Philosophy is created through experience. I mean, not everyone would agree with that though, right? Wittgenstein would say all philosophy is just language games too, at least I think. Oh yeah, like you can even say that like math is purely an exercise in language. And same with like physics. The material can block the experience of the self. Aren't you material though? Or I say I don't know what that means. Yeah. I am, well, no, I am the self. Okay? There's only one self around here. That's why you should avoid drugs? I guess so. We are chat, you are the self. We are one. Assimilate. Dawn is a true mind. We're all imaginary emanations from his mind. Exactly. You are all in the matrix of my mind. Okay, you know what? Let's actually let's look at this with Desmos. You're hungry? You should eat. The answer is yes. Oh, for the little O thing? I would suspect that that's true. Um, for n greater than m, x to the n. Okay, yeah. So this red curve down here, I'm saying is a little o of the green curve. And so that means we would need to have this be true for any multiple, oh, of the smaller one. Or x to the m. Wait, okay, so if I put a 10 in front of here, okay, if I do a 0.1, see, isn't that not true now? Or, oh no, we just need a smaller neighborhood. We need to go deeper. Desmos might not give us enough resolution. Okay, maybe proof by Desmos is a bad idea. Because x to the n over x to the m approaches 0 as x approaches 0. It's also little o. Fair. I'd like to do it like the epsilon delta way. But yeah, the limit way is good to think about. But math 2, you're just not as good at it. That's fair, Fringe. I am like a crazy person who spent years like specifically studying this stuff. So this is kind of like stuff that's out there. I don't know how to say that. Sate? I'm sorry, I don't know how to pronounce your name, but feel free to ask me the question and I can let you know. Teja. Okay. That sounds familiar. I don't know category theory. There's sometimes people around in chat who do know it. I've never even tried to learn it though. Um, yeah, it seems like a pretty weird part of math. I don't know. Yeah, that's fine, Teja. So let's write out that the limit idea. So importantly, n is greater than m so this is positive. So that's 0. Most I know is from some YouTuber makes meme videos about it. Oh, for category theory? Lazad, thanks for the follow, and hello. Welcome in. Sheafification of G? Oh, that sounds familiar. I feel like maybe I've been linked to that before. Let's see what Tej's question is. It looks kind of crazy, but... Oh, nice. Zach is awesome. We love Zach around here. Thanks for popping and saying hi here, too. Okay. Limit definition will tell you that for all epsilon there's an x close enough to 0. Okay. I'll try and actually like obtain that once we at least think about Tej's question. I'm doing well, Lazad. Thanks for asking. How are you doing? For background, I'm a master's student in applied math. And I was just before studying something for one of my classes. But if someone asks a question, I like switch over and do that instead. And so this one was just asked over in the YouTube chat. A 3-digit number ABC is called steady if its digits are in non-decreasing order. Okay. 111, 368, 234. Yep, are steady. 321 makes sense. Number is called slow if it is less than 500. We know that slow and steady wins the race. Find how many 3-digit numbers are both slow and steady. Okay. This is maybe doable. I'm doing a lot today. I'm doing psychology, intermediate algebra, and gamifying some mobile game, and watching. That is a lot of things. Good luck. Okay, I mean, I guess I would start by, like, we're starting at 100. Let's just kind of start counting through numbers and seeing what happens. 45 seconds? I am not... That's a ridiculous expectation. To solve this in 45 seconds. So let's write out 3-digit numbers until we get one. Well, okay, wait. So we already know. If we just start writing out numbers starting with 100, 10 is never steady, right? So we can skip straight to trying 110. Let me do a ... But then this 10 causes a problem. So we get our first steady number at 111. 0. Ooh. That has to be an error on the question, though, right? Because they provide 504 as an example. I guess because the 5 and the 4. Ooh. Yeah, I think there this seems like a contradiction in the question. You make a good point. Syntax, hello. If I didn't say hi already, I forgot if I did. Rutrow. Oh my. So if it has 0 in it, does it just not qualify to be steady? Like, yes. Okay. So even if we change that 504 example to 506, this is not steady. Okay, so that's good to know. So I think I can sort of see a pattern. There's probably going to be a better way to do it than I'm thinking about it. But out of the 110s, we're going to get, I guess, 9 numbers. I always feel really stupid when I do this, but counting numbers is like, I find it difficult for some reason. 111, 112, 113, 114, 115, 116, 117, 118, 119. Okay, so that's 9 numbers. Like, I feel like I really shouldn't have to count like that, but I do. What list is the one you made? I'm just counting through 3-digit numbers and looking for a pattern. Now if we go to 120, that can't be. 121 isn't. Now 122, we start being steady again, all the way up until 129. So this is gonna now be 8. Yeah, so it's gonna be like 1 less every time. So I'm going to start skipping here. So 133 is the next relevant number, and that'll go until 139, and that'll be 7. So I think the pattern, at least from the hundreds, we're going to get 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Because of 199. And then from the 200s, I imagine we're going to get like just this piece. That's my guess. Yeah, as PhD says. 8 plus 6. Do we need to be... No, yeah, we're good. Because this will be 233, and that's fine. Plus 4, plus 3, plus 2, plus 1. And then the 300s, 7 plus ... plus 1. 400s, 6 plus ... plus 1. 500, we don't want the 500s. And then we theoretically just add these up. This can be done via triple or double sum, which is by essentially be a polynomial in n. Probably. I don't know how to do that, but that sounds like something that is possible. So I guess let's take this chunk. To do that chunk, let's add up this row and multiply by 4. Let's say, okay, 9 plus 16 plus 21 plus 4 times 11, 15, 18, 20, 21. 21? 25, 46, 84. 130? Oh yeah, true, Spaghetti. That is just a Gaussian sum, right? 45 for the first one? Oh, did algebra mistake? I don't think so. That's 25 plus 26. Oh, nice. Yeah. 1 plus, like, 1 through 10 is 55. Uh, oh, that's what you mean. The first row is 45. That's fair. Okay. Thank you for the question, Teja. I'm glad I was able to actually do it. I wasn't sure if I would when I first saw it. Yeah, I don't know how you do that in 45 seconds. I guess it's not that long once you see this pattern. But it does kind of take a minute to work out how that's going to look. I don't know how you do this one quickly. I'm pretty sure this is right, Spaghetti, but if you feel like doing it, go ahead. Yeah, I don't think 45 seconds is really fair for this question. 130 is the answer? Nice. Okay. So I guess we just got confirmation that 130 is correct. Worth looking at it from the other angle. What's the other angle? Trying to like construct them? Which numbers aren't? Oh, okay. Uh, maybe. I I I don't see a way that would be quicker than what we did though. The explanation is different. Yeah, I imagine there are a lot of different ways. Okay, well, I'm interested in this explanation. For a number to be slow and steady, the first digit 1, 2, 3, 4 digits satisfy A less than B less than D. Yep. Count possible BC pairs for each A. If A equals 1, then BC from 1 to 9. 45 combinations. Well, that's... So this is... Yeah, it is the same as we just did. I just wrote more things out than they did. It's ultimately the same logic. I think figuring out this... Let me do it in a different color. Figuring out this chunk, they really skipped over that. Because it's not just... Like, B and C can't be anything. C as a constraint. You got 130 for your script? Nice. And like the PhD, you're talking about triangles. I can imagine there's some neat way of arranging the numbers to help count this too. $500 isn't a perfect square, so you couldn't make it an actual square, I guess, but syntax error put sum n equals 1 to 4 sum m equals n to 9 sum k. Oh yeah, I guess, okay, yeah, a triple sum makes sense of 1. That should do it, yeah. Because here k would be your final digit, right? M would be your second digit, n is your first. Yeah, Twitch chat kind of removes formatting. Discrete math, it's really not my strength. You can always try me with questions, but with discrete math, it's kind of, discrete math is many different things, so it's kind of difficult to study for. All you can really do is just practice. There's not really better advice than that, I don't think. Concerning 2-digit SNS numbers. Yep. So for 3-digit, you use all of them. For leading 1, all but the first one for leading 2. Yeah. Okay, nice. So that's the, I guess that's a nice way of doing it if you want to just remove the bad ones rather than counting the good ones. Any resources? Oh, that is okay. I mean, yeah, I guess so. Yeah, you're right, Jen. I might have a resource. Let me see if I can find it. This song's a throwback. Actually, I might have 2 resources. Depending. Probability theory, only a tiny bit. Measure theory, basically nothing. Okay, so first off, the open textbook library has textbooks that are completely free and legal to use that are university level. It looks like there's quite a few resources in here. Oh, this is a cool theme for a book. So you could try taking a book from here. Yeah, this website is really great. You could also look at MIT OpenCoursera, which is another free resource. And they might have discrete math courses. Yeah, like there's something, Principles of Discrete Applied Mathematics. It's not the exact thing. A class about how to learn? That's kind of funny. F and HC. Just resources on discrete math. Teja in the YouTube chat was asking. Ooh, that's a cool one. The random walks in diffusion. What does the seminar look like? I mean, this might work too. So you could try this one too. It's an actual like course rather than just a textbook. Evidence-based software engineering. This book discusses what is currently known about software engineering based on an analysis of all publicly available data. The aim is not ambitious as it sounds because there's not a great deal of data publicly available. Huh. You would think there'd be a lot of stuff about software engineering. I guess not. Or maybe it's all just kept private. Okay. By the way, just in general, in my Discord server, I do keep a list of resources that I like. Oh, there it goes. So in this like helpful resources tab, these are the resources that I tend to like link to the most often. So if you've ever like looking for something, just go here. Okay. Well, nice. We were able to get through that question. Let's shove this to another page. And unless someone wants to ask another question, we'll go back to little o and big O stuff. A Byte of Python is a free book on programming using the Python language. It serves as a tutorial or guide to the Python language for a beginner audience. If all you know about computers how to save text files, then this book is for you. Ooh. Man, I feel like starting to learn programming with Python, if you've never seen a different language, like what's a good metaphor for that? I feel like it's being taught to learn to ride a bike, but they never tell you that the training wheels are supposed to come off. Like, I don't know, I feel like Python is like too easy almost. Am I good at number theory? No, that I can do some basic number theory stuff. I'm not very good at it. Live, love. I'm not even going to try to pronounce that. The book my uni uses for advanced calc. Maybe just calc. They got another book for the comp sci folk. Oh, nice. Linear algebra. Spaghetti, are you asking for a linear algebra resource? Because it's not on either of those sites, I don't think, but there's like an open source linear algebra textbook that's supposed to be pretty good. Open textbook? Yeah. Oh, if I like it. Yeah, I like linear algebra. It's really helpful. Who said number theory? That was Teja over in the YouTube chat. And then linear algebra was spaghetti there. What books are under the student success section? Is that here? Oh, yeah. Stop expanding. Thank you. Our primary goal in writing college success is to help you succeed in college. Well, that's short and to the point. You gotta appreciate that. Realness is often abbreviated real anal. True, yep. Without clicking on the browse. Oh. Well, too late. It's like a... I don't know what to compare this to. It's like Sisyphus pushing the boulder up the mountain and it just keeps coming back down. Like every step forward, you take 2 steps back. That was a problem back in the day when I was preparing for math exams. So some of them were really cool. Oh, nice. If you want to share one, feel free. Who wrote this website? I don't know. You should write them a strongly worded letter. Now when I search for real animal on my PC, it says 2 different homework folders. They're in French though? Oh, okay. I mean, there's always Google Translate, but... No worries. Used Glibart Strand? Oh, Gilbert Strand. Yeah. Linear algebra book. Able to solve an exam question. Nice. Yeah, I also did the MIT OpenCourseware linear algebra thing. And Gilbert Strang is his name. He seems like a really cool dude. I didn't love the way that he... I mean, I did love some things about how he taught linear algebra. He has kind of an unusual approach, so I'm not sure that I'm like entirely sold on it, but I definitely picked up a lot of really helpful things from him that I didn't get from my first linear algebra course in university. Six steps to job search success. I feel like looking in newspapers is not the first step to success. I feel like it's a very poor choice for a cover. Even in 2011, like that's like you can still look at it in a newspaper for a job in 2011, but it was getting pretty online even then. Okay. But yeah, I guess that's what's in the student success thing. How to learn like a pro. Okay, yeah. That's in that tab. Welcome to building in the resume. Ask for a job. Someone's looking for a job in 45 years. My parents, when I was in high school, and everyone looked at me like I was stupid when I asked them for a paper application, told me to apply online. Okay, we say f is little of g as x goes to x naught. If for all epsilon greater than 0, there exists a delta greater than 0. Okay, so we know epsilon, we have to find delta. Try to become one of those people who gives advice based on a world that no longer exists. I don't know. Is that can go both ways, Mega. It just depends how you age, I guess. How up to date you stay with things. But also, like, you know, as like old people have wisdom. It is a part of growing up for yourself to realize that old people are people just like you. I don't know. Got a class to teach, you gotta run. Sounds good, Mega. Thanks for hanging out. Good luck with your class. Definition equivalent. Oh yeah, spaghetti. I was taught there was like a technicality with that. I guess maybe you just said what the technicality is. They didn't say what it is, but yeah, they did say that they're nearly equivalent. I want to know how to use the epsilon delta thing. So I'm really not good with epsilon delta. Well, people aren't like me because almost nobody's like me. Hey, you know, there you go. Supposed to start my mandatory military service. I was there for 4 days. I got some stuff I don't care to explain. Now I'm home waiting for a diagnosis. Oh, told me anyone to be attending. I hope you can get back, and I hope that you're all good. Yeah, best wishes to you. Hopefully you can get back in. Um so I'm saying x to the n is less than or equal to epsilon x to the m. And that n is greater than m. Oh, I mined all of the epsilon delta stuff that I've done. I mined it a lot. It is not my favorite part of math. So this is a different version of epsilon delta stuff. I assume you've only seen it with limits, but maybe you've seen it in other contexts. I'm trying to learn about asymptotic analysis, which is like little o and big O notation, if you've seen that. I'm trying to understand the actual mathematical definitions of little o and big O is my goal for today. And they're defined pretty much in epsilon delta terms. It's apparently the definition I have for little o here is apparently nearly equivalent to this statement with limits. I want to learn the epsilon delta thing though. Or it's like I want to be able to do it for some basic examples if nothing else. And once I've gone through and I feel like I can at least apply the definitions for myself, I want to learn what like intuitively it means too. Isn't f approximates g if limit x to infinity f over g equals 1, or limit x to infinity f minus g equals 0 depending on definition? So you can use little o and big O to define f approximates g. How we've done it in class as of yesterday, which I need to understand this too, but one step at a time. Trying to find it. 1 second. Yes. Planet Engetree? I'm sorry, I'm probably saying that wrong, but thank you for the follow. The f approximates g thing. Okay, this definition is a little bit involved. That's phi. x goes to x naught. And I'll define asymptotic sequence also. Oh shoot, there's more. I should probably just look for this definition in the textbook. It'd be easier than me typing it out, but I feel like I've already committed to doing this. f of x minus a sub n phi sub n of x is equal to little o phi sub n phi sub capital N. As x goes to x naught. We write f approximates n equals 0 to infinity a sub n phi sub n of x as x goes to x naught. Okay, let me catch up with chat. I really want to know if there are methods to solve for asymptotic solution to differential equation when the analog solution doesn't exist or is really hard to find. I think that's what I'm going to learn in this class. Because the method is called Advanced Methods for Ordinary Differential Equations. I assume that's the type of thing we're going to find. Phi sub n is a sequence of functions, which I will define now. E sub n plus 1, so little o, phi sub n, as x goes to x naught. Okay, so basically each function is little o of the previous function. So what is big O of f of x? Big O is this definition here. It means that you can find... It means that f is bound above by g in some sense. You just need to find a single pair. Like, if you can find any scalar multiple for g that works in any neighborhood, then you're big O. Um, and so I think you could say like a thing that I was like planning to like think about today is that if x is going to infinity, you could say that x is big O of x squared, but I think you could also say it's big O of x cubed. No, not every. You just need to find a single pair that works. Yeah, so like it's a little bit weird. No, I've been thinking about this stuff all week, and I don't feel like I've made that much progress on understanding it. So if you just understand it instantly, then you would be like God. The C is evil. I mean, the C is actually helpful because it makes it so you can just care about the form of the functions, and like we don't care all that much whether there's a scalar multiple. It lets you ignore issues with like the constants, I guess. Jed linked something that explained why that's a nice thing. Or wait, was that in Jed's link? Yes. I'll drop the link again in chat. It's basically that's the reason right there why C is a good thing. Hey, Energy. So you can say I guess a quadratic is still big O of a quadratic, even if your exact quadratic would be smaller or bigger. Yeah, sure. Energy. Feel free to ask it. And so and yeah, like see, like I don't think it's normally very exact. Like it's not like there's a single C that works. Yeah, the equal sign is confusing. I am also confused by it. um I don't exactly know what to I feel like the it's more like an inequality than an equal sign. And I think the equal sign is just there for like, I don't know. What is the O of f of x set? Yeah, it's like like O isn't really a function as far as I know. It's just like a notation. Like it, I don't know. That's a good question. Like what O actually is O, big O? Are there any techniques to sum over large numbers? Um, like are you trying to like get good at mental math, or are you like programming in a computer, or do you have like a pen and paper and you're trying to do like 1,583,621 plus 54,174,369? I don't know. I assume maybe you mean something like this where you have a pen and paper and you're trying to add two big numbers like that. But maybe I'm misinterpreting you. mean, what does when one does a summation? Oh, okay, yes. Is there a way to do it? Oh, okay, yeah, yeah. This is a great little exercise. So if you want something to Google, I would look up Gaussian sum. It has a bunch of different names, so it might be some like version of that, or like Gauss's sum, maybe. But I'll explain what it is. So it sounds like what you're asking about is sums of integers. So actually, before I give you notation, in if you have 1 plus 2 plus 3 plus 4 all the way to 10, we can write this in a more compact way using sigma notation or summation notation. And so this is Greek letter capital sigma. If you already know this and I'm explaining something you already know, I'm sorry. But in case you don't, I'll explain it. We'd say that this sum from 1 through 10 is the same thing as sigma. Oh, okay, you know it. So let me just write it then. From n equals 1 to 10 of n. So these two things are the exact same, but this one is a bit easier to write if you want to sum like 1 through a million. You definitely want to use this notation instead of that notation. And also, if you have more complicated things inside here than just n too, is another situation where you might want to use it. And the cool insight for how to work out this problem, let me actually just, it's worth it to write out the entire sum here. There's a trick to figuring this out without having to add each thing individually. And you need to pair these up in a smart way. So there's a story about how Gauss discovered this formula as a kid. His teacher tried to punish him for being a smart aleck or something by making him sum the numbers 1 through 100. And according to the story, he figured this formula out to just do it really quickly. And the trick is that if you sum the first number 1 and the last number 10, you get 11. If you sum the second number and the second to last number, you get 11. Same thing, 3 plus 8 is also 11. So if we keep repeating this, we're going to have 1, 2, 3, 4, 5 11s. Is equal to 55. And if you were to go through and sum all these up, you would get 55. Is this Taylor Swift? Okay, well, I'm glad the FA already left, because this is Taylor Swift. Use that trick in Rummikub. That sounds kind of familiar. See if your run equals 30 points. Is it just called Rummy also? I might have played that, but not since I was a kid. It's a tile game. Oh, maybe I haven't played it then. I'll look it up in a second. And so we can take this pattern and write it as a formula. So, oh yeah, it's a good song. I just wouldn't want to admit it to a Swiftie. So instead of 10, let's just make it an arbitrary stopping point. So I'll call it, what's a non-confusing? I'm gonna call it, okay. Instead of small n for the index, I Swiftied you? Oh no. I'm gonna use k as my index, and then oh no, that's still confusing. I'm sorry. I'm debating way too much about that. I'll say capital N. So instead of 10 for a starting point, we just have some capital N and ending point. The easier bit to see quickly is that 11 is 10 plus 1. So for our general formula, we're going to have capital N plus 1. This 5 comes from... We have 10 numbers here, and then we have to cut it in half because we put them in pairs. So it's n divided by 2. And so I usually write this formula... I mean, it doesn't matter how you want to rearrange it. I like to write it like this. It doesn't actually matter. You could also say this. This is all aesthetics. But yeah, so basically this is the answer to your question here. And what's even cooler is that you can get similar formulas for 1 squared plus 2 squared plus 3 squared plus n squared. Same with cubes. And actually for any integer power, you can get a formula like this. It gets more and more complicated, but you can get it. I don't know if it uses the same technique though. I think you have to... I don't... The idea with pairing doesn't work. I don't think, but... Yeah, thank you for the question, Energy. I'm glad to hear it makes sense. Let me know if you have any other questions. Let me see what Rumacub looks like. Wait. There's Rumacub tournaments and championships. Oh no, I definitely have not seen this before. Your dad used to have it? Oh, so it is related to Rummy. Interesting, because I played Rummy. I don't remember how it works. "106 tiles, 2 jokers." Oh. It's a classic game for old people. Someone's my dad for Christmas. Okay. Interesting. Different game. Your friends actually have this game, you pretty much always lose. Yeah, I've played like cribbage too, which I think of as like an old person's game also. As a kid, my mom had us play a fair bit of old people games, I think. Yeah, Zach, I was just learning that even exists. I never heard of it. Oh, I didn't do the epsilon delta thing yet. Oh yeah, that's right. I got busy explaining the asymptotic sequence, asymptotic expansion stuff to syntax. Hey, Skirtle. Out of curiosity, how does one find the formula for the powers of integers? That's a good question. I forget. I've done it before, I think. Um, been for ever since I played it. We had the game in our house when I was young. Oh, okay. What's powers? It's like a Gaussian sum, but with powers like this. I have fall havers. And so I guess at FNHC, I'm not sure what your background with math is. If you want me to explain like more about like what I mean, let me know. But it's basically like this here, but like it could be like 1 plus 2 plus 3. It could be 1 squared plus 2 squared plus 3 squared, 1 cubed plus 2 cubed plus 3 cubed, all of that. K equals minus 1 diverges. That's true. Even for, oh yeah, okay, yeah. Or P equals minus 1. Well, also K equals minus 1 though. I guess the K equals 1 doesn't make sense. Well, yeah, I guess. Um, this is probably too too. This is probably a bad one to jump straight to. But if you want, like Faulhaber's formula is the generalized thing for any power. I want a simpler explanation for just like squares or something. Oh, wait. Wait, what? Really? What's happening here? I don't understand what this person is doing. Let me catch up with the chat. Calculus by Michael Spivak has an exercise in chapter 2 to guide you through coming up with the formulas. Some exercise in later chapters actually paint the entire picture. It's not super easy for... Yeah, for general, okay, but we could do it for squares for sure. You are possible, Zach. I think you are. I've done it for k squared before. Uh, I think maybe what you do is you consider k plus 1 squared minus k squared. Oh, that's a cool one, Fluffy. I don't know how you find that. I'm just gonna mess with this quickly and see if I can make it work. I don't remember how you do it for n squared. I thought I could do something with this recursive sequence. It's not coming to me now, though. But yeah, Kim is possible, but not Zach. True. So non-visual proof. Oh, yeah. Visual proofs are much more fun. Guessing a good question, Energy. I can't quickly remember. For a particular power, you have to go like case by case. I don't think there's a good pattern for all the powers, unless you want to go straight to like Fallhaber's formula. That is weird, and I don't know that one. First, oh, but it's just n squared, not sum of n squared, right? Sum of the first n cubes. So this is doing it for the cube case instead of the squared case like I was trying. Do a sum of sums. I mean, I don't know. I'm not going to know how to simplify that, I don't think. Wow. This is a crazy proof. You can take these cubes and flatten them out into a square. Let me cook? Yeah. I think that there should be a neat way of getting to the sum of squares. I can't remember it, though. It's just not coming to me. Hey, Broral. Broral. Hope you're doing well. The scintillating starburst. What's going on with this? Oh, that's like an optical illusion. Oh, this kind of hurts. This also hurts. Oh God! Oh no! No! Oh no! I can't do that. Sorry. That's why I can't do like I can't do dark mode for websites because certain things like that hurt my eyes, and that spinning one was like the worst one. Oh geez. Do a minesweeper? Oh yeah, we can definitely do a minesweeper. Sum of cubes is square of sum. Yeah. Oh, I'm not doing an evil. All right. While Fluffy cooks, I'll do a minesweeper. Bam, bam. Thank you, ma'am. Okay, there we go. 43 seconds. Do a barrel roll? What would a barrel roll be? Would I just spin around in my chair? And is that a barrel roll? Okay, can we get a full 360 in one push? Let's see. Oh yeah, okay. Oh no, that's not. That was like a 330. That'll be a yaw roll. Okay, well, I'm not gonna get down on the ground to do a barrel roll. Sorry. Okay, we'll be starting with the difference of two cubes. Use this to show n plus 1 cubed minus n cubed. Sure. I don't know the difference between like pitch and yaw and all that. Pitch, yaw, and roll. Let's see. I mean, this is relative though, right? Nose or tail up. Okay, sure. So any yeah. uh, yeah, I don't know. Um Interview between Joel David Hampkins, Lex Friedman. Yeah, sure, energy. I won't like look at it now, but you can post it if you want. Everything's a barrel if you define your axes right. Makes sense. Okay, let's follow Flofi's logic here. Wait. Coldplay heavy. Yeah, I just put it onto radio for Ed Sheeran, actually, and I guess Spotify thinks Ed Sheeran fans also like Coldplay, I guess. Okay, what's happening here? We know that n plus 1 cubed minus n cubed is 3n squared plus 3n plus 1. The sum from 1 to n plus 1 of this expression is a telescoping sum. Oh, okay, like the sum of this thing is a telescoping sum. So n plus 1 cubed minus 1 is equal... Okay, so... This is confusing notation. I need a different index. We know by telescoping sums, this is equal to n plus 1 cubed minus 1. But we also know it's equal to sum from k equals 1 to n plus 1, 3k squared plus 3k plus 1. Okay. And now we just need to isolate the sum of k squared, and then we're done. Okay. left behind my +1. So working with this equation here, let's see if I can get to the right answer. Using properties of summation, we can write this as k equals 1 to n plus 1 k squared plus 3 n plus 1 k plus 1. Well, sum of 1. N plus 1 cubed minus 1 equals 3. K equals 1. N plus 1 k squared. Now we can use Gauss Sum on that. It does go until n plus 1. 3 over 2, n plus 1, n plus 2. That's just n plus 1. You were taking it to n? Oh, well. I was following that n plus 1 you wrote there. Oh, okay. I was just gonna do a change of variables at the end to fix the +1. But if it's not necessary, then I should avoid it. Yeah, actually, what I wrote was actually wrong. So, yeah, never mind. And then rearrange things. K equals 1 to n, k squared. N plus 1 cubed minus 1 minus 3 over 2n, n plus 1. It's a bad 2. Minus n. I don't think there's a way around just multiplying this out. Unfortunately. 6, 7. Indeed. N plus 1 cubed is at least quick to multiply out, because it's just that. Minus 1. A cast? That's true. Yeah, Fluffy, you did kind of set yourself up there. Not gonna lie. N cubed. Plus 3 over 2 n squared. Plus 3 over 2 n. Wait. Nope, 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 no, no, no. Okay, just 1/2 n. No. Plus 1/2 n. and that's it. Hopefully we can factor this. I don't know why I'm doing all this. I'm committed though. Multiplies to a half adds to 3/2. 1.5. I'm pretty sure that's the right answer. It's usually written slightly differently though, right? Yeah, it's written as syntax has it, and that's equivalent. Just multiply the top and bottom by 2/2. Nice. Good spot there, Floppy. Hey, Ayush. Is there another sick and twisted way to get this? What is it? I love sick and twisted math. Using combinatorics? Ooh. I I know like Fallhaber's formula has a combination in it. Is there one specifically for like squares? +1 sick and twisted? Ooh, we got +2 sick and twisteds. We want to know the dark arts. No worries, Ayush. Okay, while syntax cooks, I might go back to the little o problem for a bit. That +3 sick and twisteds. You'll love to see it. If we keep this up, we're gonna need Gauss's sum. Actually, no, we won't. That's a bad joke because it doesn't work. Just following the crowd. In this case, I approve of that. +2. Oh, there you go. Just to be a rebel. You should have said +e to the 2i pi. Or to be Fibonacci, you decide. So today, Flippy, I've been, if there hasn't been a question from chat, I've been trying to learn about little o and big O notation. And so just as an exercise that I made up, I want to try to improve that if n is greater than m, that x to the n is greater than, or is, oh my god, that x to the n is little o of x to the m as x goes to 0. And I want to do it the epsilon delta way. We already looked at the limit, kind of nearly equivalent definition. But I want to do it the epsilon delta way to get practice. Isn't that, you think it's false? So yeah, I did it for big O before, and I guess I was asking if it's true for little o also. I thought it might be. Like the limit seems to work out. But I may have tricked myself. It's definitely false for little o. Hmm. See, Zach, that's also what I have written. But like I guess I was trying to figure out how to find a delta. I don't know. Let me. Okay, so I'm gonna read syntax's sick and twisted thing, and then we'll look at energy's question. And then I guess we'll come back to the little o question. The small one is little o, the big one. Um, so I've already shown the case for big O. That's what I did here. But big O is like, it's easier for something to be big O. Small o is harder to show. I want to see if it was, so I already know it's big O. I want to see if it was also small o. But since the limit seems to work out, I would assume it is. And Spaghetti earlier in chat posted an idea for how to do the epsilon delta thing. No, n greater than m. So I might bring up Spaghetti's message history when I come back to this one. Yeah, it is confusing with the powers because we're going to 0. The bigger power is smaller. Okay, but f(x) equals sum k equals 1 to n. E to the x. I assume k is also in the exponent since you're saying geometric series. Do the geometric series for this. Yes, okay. Then take the derivative on both sides. Okay, well, the geometric series. I assume x needs to be less than 0. Then take the derivative on both sides. Oh wait, well, if no, it's finite. It's finite. It's finite. It's finite. It's finite. It's finite. It's finite, guys. What's I never remember the formula for. Is it 1 minus e to the xn over 1 minus e to the x? I think it's that. Hey, Vossen. I'm gonna see. Oh, n plus 1? Really? Okay. Start from k equals 0? True. Well, Yeah, or can we just fix it though? Because I kind of want to, we probably want to keep k equals 1. Yeah. It's really n plus 1? Maybe I'm just misremembering the formula. Let me see. Geometric series sum. It's a matter of, but I'm still concerned about the plus 1. I want the summation. Okay, this seems to imply that there's no plus 1. This is also starting from 1. Okay, you know what? I don't feel like thinking about it. If you guys are saying this is right, I'm gonna go with this. um. Derivative with respect to x, I would assume. But yeah, because it's a function of x. Yeah. Um. We don't lose any terms, so the bounds aren't going to change. Quotient rule. Ugh. Low d high minus, I need more room. High d low over low squared. The sum becomes equals derivative of something, then limit x goes to 0 from the left. You get sum limit of derivatives closed, the closed. We're taking the limit as x goes to 0 from the left. You don't think the left limit matters? Okay, well this behaves like e to the 2x, right? How does the top behave? Like, I also e to the 2x, I guess. So the limit probably works out. Oh! Okay, I think I'm picking up what you're putting down. Because the limit on the left side will become just the sum of k. Wow, this... I guess that would probably work for k squared also. That is sick and twisted. It is another Coldplay song, Fembucks, you're right. So I would prefer not to do this limit by hand. I'm just gonna say that it's n plus 1 over 2, and it's an exercise for the chatter to prove me wrong. Let's look at what Energy posted. Sorry to keep you waiting, Energy. Is this real math? Because I can't understand this personally. Let's see. Okay, I'm looking at the queue. Oh my, okay, there is one more Coldplay song. But there's like 6 other songs after this until it's going to run out, and I'll have to switch the playlist anyway. The page is taking its sweet time. Stop. Stop. Refresh. There we go. Lacanian psychoanalysis. Lacanian algebra. What the hell? The real phallus? The symbolic phallus, the imaginary phallus, castration. The statement, oh gosh, I can't say I've ever heard of this. Lacanian algebra? Let me just Google that and see what comes up. Is this an attempt to like use math to do psychology or something? Oh, wait, this is just algebra. Uh wait, what? Okay. Lacan. I would need to see what Lacan is actually doing with this. As to whether it's real. When someone does something like this, it's usually an attempt to make a soft science become formal and like just as black and white as like physics or math itself. And it's usually not successful. Maybe it does experience success in some like narrow context, but not like generally. I'm kind of basing this off like economics, how people all the time try to make that formal, and it looks real, but it isn't. Nice. Oh, I wasn't even thinking about that RCR, but yeah. Lacant. That's the link that I'm looking at here. I can't vouch for this website. I don't know what nosubject.com is supposed to be about, but some of first n naturals cannot be calculated through combinatorics. Oh, wait, can be calculated through combinatorics. Oh, that's interesting. Ayush. Um, I don't think I want to look at Reddit. I would be very skeptical of this. And the thing that you would really want to look at are what fundamental assumptions is the author making, and try to think of assumptions the author implicitly made but may not have thought about. That's usually where something like this would fall apart. There is an active subreddit, apparently. This isn't really... that's my guess, Energy, from seeing similar things to this. Maybe this is an exception somehow. But I'm not aware of any like successful attempt to kind of generally take a field like this and formalize it using math. So I don't know. At best, quirky approach to psychology, at worst, quack science using faint symbols to hide the bullshit. Yeah, I think you have to be careful of with this type of stuff. Okay, well, we're not going to read this entire thing. Let's at least read the first little bit of this. Let me post the link in the Twitch chat in case someone wants it. So this person is... So I know nothing about where this paper really comes from, or who the author is here. But if this person is to be believed, Lacan's work appears to be seen by authors, the authors that are mentioned above here, as arguably the most notorious case of this alleged abuse of math and science. Some of Lacan's statements they cite were bound to attract a special attention, which prompted my friend's email. It said, does Lacan really talks about the penis and the square root of -1 with a straight face? As reported by in Saturday's New York Times article on the SoCal and Brickmont book. That's okay. I apparently Lacan tries to make a relationship there. I am testing the limits of my open-mindedness. This seems to go beyond them. Oh, Lacan... It's not talking about the penis necessarily, maybe. Uh, so if I were to give this a fair shake, I would actually read Lacan's work and try to understand it for myself. But from reading other people's opinions on it, it doesn't seem to be very successful. You can, even in math itself, you can make really complicated looking statements that other people that look impressive, but it's only because they're too complicated and they're either wrong or they're not actually saying all that much without even having to leave the realm of math. This might be a friendlier article towards Lacan's thinking. I don't know though. I think I'm gonna drop this topic in a second here, but um if it was a big deal, I probably would have heard about it sooner or something. Yeah, I'm not sure what else to really like say about this. Let me catch up with chat. Closest I've seen to using mathematics to successfully discuss concepts in the humanities is type theory applied to linguistics. That's cool. It's actually quite successful, though still imperfect. If you're interested, you can look up typological semantics. Okay. If I could, I would time travel and get Freud to read this and then bring him back to the past so he may invent this before Lacan. Okay. I would read Lacan's work and try to get an understanding. I mean, that's to be fair to the other side of the argument. I'm not going to, but I feel like if I'm going to express an opinion, I need to qualify it with that. Even with the minimal background psychology that I do have, I can tell you that you're going to be there for a while. Leaves their own hard psychology and some philosophy. Probably, yeah. Changing all my zeros to sine squared plus cosine squared plus e to the I pi. Yes. That's a great way to make your math look needlessly complicated. Let me catch up with what Ayush was saying about getting Gauss's sum using combinatorics. Now if we go sequentially and take a equals 1, we have n choices for b. If we take a equals 2, we have n minus 1 choice for b. Ooh, okay. We can get the number of choices directed by using the formula n plus 1 choose 2. Okay, nice. That's cool, Ayush. Thanks for sharing that. Okay, unless someone else wants to bring up a topic, we'll go back to little o. Oi. So if n is greater than m, it'd be cool if I could show x to the n is little o. I mean, make that o even smaller of x to the m. Yes. Seem like n squared is big O of n cubed. So it's all about the point that you're approaching. That's what makes the difference. Because at least in the definitions that I was taught in class, you are big O or little o in a neighborhood of a point. Not for us. So this is an example that we did in class that I worked back through, where we did big O about 0. And so that's part of what's throwing me off here, which I feel like I've normally, like, I've never seen big O and little o be in reference to a particular point. But yeah, it will definitely get flipped. Like, 1 is like the critical point where things kind of get flipped. Or -1. Well, the negative might be trickier, but... It's like, just to, like, so I was also curious about that, so I did do a case, like, around 2, just to get, like, for big O at 2, just to get, like, the reverse order. And I think I did it right. I hope I did. I had to do, like, an inequality trick, though, which is always... I don't know. They always feel sketchy. Okay, so if we know that x to the n is less than or equal to epsilon times some x to the m, how can we find delta? I guess we know that x to the n minus m is less than or equal to epsilon. This is a positive number. Oh. I found delta. And so theoretically, if I was being super rigorous, I would do like the reverse of this and like randomly choose this to be my delta and then show that this original thing is true. Oops, that's not right. There we go. If something is less than, it's also less than or equal to, I guess. There's a slight weirdness with the signs. It shouldn't really matter though, I don't think. If I'm saying this part on the right is the actual proof, I think it's fine. Hey Jermaine, I've been good. How about you? Just been getting back into the swing of taking classes. All right, well, assuming I did make a stupid mistake, I think I did show that x to the n is little o of x to the m as x goes to 0. Okay. How have you been, Jermaine, if I didn't ask you already? Yeah, I haven't been streaming as much as I used to be, just because I started on a master's. Yeah, exactly. Glad you're able to catch me though. Okay, so let me get into the textbook because there's a lot of things like when you see big O get used out in the wild, they're not usually very specific about what they're doing with big O. There's a lot of like implied things. And I think the book kind of addresses that, and I want to reread that. So yeah, big O concern ourselves with statements claiming that one function serves as a bound for another. Ooh. Yeah, that I forgot. So in class, we never learned this first definition. This first definition is not around a point. It is everywhere in a set. For all points in a set. It's really not that bad, or it's really not that different though to say around a point. Say this is the definition we were actually taught in class. The as z to z naught from d, like the from d part is a little bit curious to me. That's maybe saying the path that z takes to z naught is contained in d or something. So I get the same definition at the stock of z0? What is the stock? We have a slightly different definition for infinity. It's true at z0 if it's eventually true at any small enough. Yes. For big O, like you don't even need to be defined at the point. You just need it to be a limit point. So then for infinity, you just find a number m that's like your kind of minimum cutoff point. It doesn't even have to be a minimum, but just some cutoff point after which everything else always works. And so, yeah, I guess like a weird thing you just have to get used to is that if something is O of x squared, it's all, or big O of x squared, it's also big O of x cubed, or big O of e to the x, or like, it's not like unique, is the part that's kind of weird to me. Well, one of the parts is kind of weird. All polynomials are locally linear, so that's not very surprising. Yeah, I mean, it's not surprising. It's just like it's like it I don't know. Just that there's multiple choices is something that I have to get over. Hey Kyo, hope you're doing well. So Morley is saying the same thing as biggest term dominates only when you look at x going out to infinity. Yes, or going to infinity. Some authors use tilde instead of equal to capture that. It's been a while though. Yeah, it is Coldplay. You're correct. The song Magic. Twiddling. Yep. Twiddle, diddle. We twiddle asymptotic expansions. That's what we twiddle in this class. I remember learning about that on stream and having a moment about why we would choose that as a name for something in math. It is fun though. Trying to find where we twiddle in this book. I have the twiddling in my notes. Here's a twiddle. But I want to find the actual definition. Ooh. Better than clopin? That's true. Asymptotic sequence. We're almost there. We're almost there. Oh, here's the twiddle that we learned about in class yesterday. I need to get a new playlist. You know what? Let's listen to the song. Put it on the radio for that. I'm gonna turn it up just a tad because it's a banger. So yeah, we're using twiddling for asymptotic expansions, which I really don't understand these yet, but I'm taking it one step at a time and starting with big O and little O. The song. Mm-hmm. Oh. The Pop-Tart Bowl? That's hilarious. I'm staying quiet because I want to listen to the song. They're straight up Pop-Tarts? I'm reading through this example here. Choosing m equals 10. Baked into a very large Pop-Tart after the game. Oh my god. I assume the Pop-Tart, the company that makes Pop-Tarts had to pay a fortune for that. Not Gary, but a pile of Pop-Tarts. Hey, Color Cone. Counter Freak, thank you for the follow. Color Cone, I feel like I haven't seen you around in a minute. I hope you've been well. I mean, that's a good tangent, Zach. Cannot blame you. You've been away? Oh, okay. I guess that explains it. Magnitude of z is greater than 10. Okay, I guess that's fair. Okay, that's the song. Let me turn it back down before I forget. You have a course grading scheme. Course whose grading scheme is everyone is getting an A? Oh, sign me up. Oh yeah, this is a neat big O problem. Proving that log grows smaller than any polynomial. No matter how small the, actually, I mean, is that polynomials are integer powers, right? Are they? Right, yeah, yes. Or maybe even just natural number powers. I don't know what you would call that, but z to the p. No matter how small p is. Right, just natural numbers. Power functions are general. Okay. Makes sense. Yeah, you gotta use this trick by expressing the log in terms of an integral. It's because you're enrolled in 8 courses? What? Are they full-on courses? Are hopefully those are mostly like baby courses? Like once a week things? Like seminars? Yeah, Fluffy, that makes sense. About like Laurent series. Yeah, I agree, but why? Somewhere the core course, you can skip them and just do the assignment. Really? That feels like the opposite of what you want to do for a core course. Color can crush 8 courses? I mean, I believe it. That still sounds like a lot of time, though. Summer seminar, which are the most interesting ones. Okay. That's where I'm at with my classes, because I'm not really excited for this class that I'm looking at now, which is for my asymptotic analysis with like ODs class. I'm not super excited for my biology class. I hope I'm wrong about the biology class, but so far I'm not too optimistic. I am excited for my scientific computing class with data, but then I'm also interested in like a seminar that I signed up for on pedagogy and applied math. I hope that one's going to be cool. No, it's a full-on class for the biology. The only seminar I'm in is the pedagogy one. Okay, what's this example here? Let d sub theta be the closed symmetrical sector about the positive real axis of opening angle 2 theta. Okay, I can picture that. Then if n greater than 0 is any positive integer, we have e to the minus z is big O of z to the minus n. Is it? As long as theta is less than pi over 2. Really? I need to think about that example a bit. Like, just got back, I'm doing okay. Going to practice / revise multidimensional array. Oh my god, I can't talk. Multi-dimensional arrays a bit tonight. Noish? I'm doing good. Thanks for asking. Just got through my first week of classes, trying to kind of get caught up with the lectures for one of my class where it kind of had, like sailed past me, I feel like. So I feel like I made some good progress so far today. When I did my directed reading on fractals, when I did the seminar class on asymptotic analysis in nonlinear waves. Those are interesting with respect to content. Okay. Yeah, hopefully the asymptotic analysis turns out to be cool. This is like, for asymptotic analysis, like the PhD level class that I'm doing this quarter. And the TA did warn us all that this class is apparently significantly harder than the applied complex analysis class that I took last quarter. And last quarter that was my PhD level class. So hopefully this one isn't that insane, but it might be. If you sow your wild oats, hope for a crop failure. What? I don't know what that means. Why would you hope for a crop failure? 8 to 9 out of 10 out of difficulty? Okay. I don't know what nonlinear waves actually are. It kind of sounds cool from the name, but it definitely doesn't sound easy. KDV. Oh, I've heard of that. I forget what it is though. Let me Google it. Yeah, this feels familiar. Counterfreak, welcome in. How do you go about showing if a set is a closed Jordan region? Like in the complex analysis? Is that where, or probably Jordan regions are more general. Oh, well, okay. I did walk right into this one. Jordan region math. this thing. Showing if a set is a closed Jordan region. Um, it's a good question. I'm not sure that I definitely haven't done this for myself. Hopefully I can find something that helps us. Yeah, Dessen. Jordan content 0. This stream is Jordan content 0. uh how do you go about showing if a set is a closed Jordan region? I mean, I assume this is talking about a specific set though, right? Like I don't know. Kind of freak. I'm not sure that I can do this problem. I'm hoping to find some resource that I can at least like point you to. Was most intuition was won by Jordan himself. I mean, I don't. From how I'm interpreting Counterfreak's question, it's not exactly a proof of the Jordan curve theorem, though. Maybe I'm interpreting it wrong, though. Shikarchi? I don't know if I have that one offhand. I know you mentioned it before. I can see if I have it. Checking, checking. Okay, no, I don't have it offhand. Wait, let me check this folder. Oh no, I do have it. Look at me go. Live stream requires a lot of care to show there is no bijective continuous map from R to R2. Oh, interesting, yeah. Yeah, I guess bijective probably wouldn't be possible. I believe it. Ooh, it's all the way in an appendix. All right, appendix B. I guess there. I mean, maybe maybe Counterfreak is just asking for a proof of this theorem, basically. Mm. Yeah, so Counterfreak, I don't think I'm going to be able to understand this proof for myself and explain it. If you want, I can try and like get this section into the book to you somehow. But otherwise, I'm not sure that I can really help you with your question, so I'm sorry about that. Subjective math. Okay. There is a continuous map from R to R2. I mean, well, I think about it in the wrong terms. I was thinking of like, if you can make a map from like the natural numbers to rationals, it's not too surprising to me that you can map R to R2. But maybe the idea is completely different, and that's the wrong thing to think of. Okay, yes, surjective makes more sense. My professor just showed us how to show if it if it is a closed Jordan region, but not the proof behind it. Yeah, that's probably for a reason, because like this proof is notoriously difficult for relative to how simple the statement is. Like it's probably the most famous example of that I can think of. So that's probably why your professor skipped that. um, there are quite a few like discussions on this out there on the internet, though. If you just look up Jordan curve theorem, I just don't really know it for myself, so I have a hard time commenting. So I'm sorry about that. And since you are new around here, whenever I do see a new person, I do like to let them know that there's a math, there's like a math niche on Twitch. It's not just me. I can't think of anyone who can particularly talk about this, but in case you ever do have like another question or thing you want to talk about, and I'm not around, there's a whole bunch of people who stream math also. It's like Zach or Eats the 2i Pi was just in here earlier. Colorcone isn't on the list, but also streams sometimes. I would bet if someone could talk about the Jordan curve theorem, maybe Colorcone, but I don't know how up to date he is on it. So, I believe generalized Cauchy theorem is with Jordan curve. This is my single complex variable class. Okay. Wait. Okay. So wait, I learned generalized Cauchy theorem as well, wait. No, I'm thinking of generalized residue theorem. But Cauchy's theorem is integral around a closed path is 0. But maybe you can generalize that to higher dimensions. General formulation. Probably, I'm betting this. It's a result from topology. Ooh. If gamma is homotopic to a constant curve, one can be continuously deformed into another. Oh, okay. The upper bound one. Cauchy-Schwarz is an upper bound one. When I think of Cauchy's formula, I think of this basically. I mean, more like that, but... Oh yeah, I only just recently found V-Enhance. I rated him a few weeks ago, I think. I'm not super into competition math for myself, but he is really impressive with the math that he can do. This version of that game has a Jordan curve? Oh, really? He is, yeah. But yeah, I guess like my background is I'm a master's student. I'm studying applied math. So the things that I'm into are like differential equations and like modeling stuff. Oh, it's an anagram of his name. What would his name be? Evan? Evan Cho? Maybe? I don't know. Okay. Um oh, maybe yeah, I lost track of the letters. Wait, oh yeah, why do I think there's an O in there? Keo, I'm currently a master's student. I've applied to continue on for a PhD. I won't hear back on that for like at least a month though. Hey, Sutikshna? Sorry if I'm saying that wrong. Welcome in. O of z to the minus z notation. Wait, I've been trying to learn the big O notation today. That's been the mission. To the minus n? Yeah. All good. Oh, no worries, Kyo. It's easy to get it mixed up. Thank you, thank you. I'm not going to shade this. So this is the region that we're working in. If n greater than 0 is any positive integer, we have e to the minus z is big O of z to the minus n. Oh, okay, so this is basically saying that exponential decay is faster than polynomial, or decay, I guess. Decay isn't quite the best word there. Or polynomial isn't quite the best word there. It's exponentially faster, you might say. Then you have to an all-nighter of solving calculus? Oh, geez. That sounds tough. Been doing exercises with disk automorphisms recently. Still don't have a good feel for it. Good luck. That I pretty much only just learned about the actual definition for big O and little o, and I'm not very good with it yet. So if we want to show e to the minus z is big O of z to the minus n, I should take the book's definition for a set, because the definition I have is around a point. It's a complicated group automorphism. They're saying magic words to me. Oh yeah, I don't really know what a disk automorphism is, but I know it's vaguely other shapes being equivalent to disks in some way or something. I don't know. Okay, so we know the magnitude of e to the minus z is bounded above by 1, is it not? Because like the best e to the minus z can possibly do in this region in terms of its magnitude is just right at the origin. And z to the minus n is going to blow up to positive infinity as we approach 0 from the right. So this should work out. I mean, I don't think this is a useful bound for the problem now that I think about it. Maybe it is, but... Great poster. Oh, thank you. Are you a Fallout fan? I do love it. It's actually even an actual flag. I think this bound, it doesn't help me for the actual for the first part of the problem, like that one. I think I did just show that it's big O of 1 though, as z goes to infinity. Maybe for let's write that. No. Okay, and then e to the minus c is large O. Make it larger. On d theta. We probably want to think about the power series for E, I guess. Uh... Really? We're saying for large Z. Well, yeah. Oh yeah, okay, yeah, we're saying as Z goes to infinity. So actually, I grabbed the wrong definition. I missed the Z to infinity part. That's gonna make this easier, I think. Hopefully. I think my brain is starting to get cooked. If we can work through this one, we might call it, but we'll see how we feel. Ooh. Ugh. Wait. That's not a true statement. Oops. That's not a purely imaginary number. Wait, yes it is. It's minus Z. Yes, okay, that is a true statement. Never mind. It needs to be true that theta is less than pi over 2. Why would that be important? Should we take things to polar form, maybe? Ooh. Hmm. I wonder if this proof is maybe they didn't show it for a reason. One over Z to the N is 1 over 1 minus Z to the N. Right? And because of the region this is defined on, the magnitude of Z to the N is always less than 1. So we're fine to make this a geometric series. So this becomes 1 plus Z to the N plus Z to the 2N Wait, oops. This isn't right. One plus 1 minus z to the n plus 1 minus z to the n squared. So that's this is a little bit harder. Try it with sine of z, maybe, then get e to the z. I'm not sure where you're going with that. If it is, well, no, I'm not sure of the relationship between sine of z and e to the z in this context. Like, we don't know that sine of z is always greater than e to the z, do we? I don't think we do. Yeah, z is complex, collar cone. If I can't get this question, I'm not that worried about it because the class is only going to be about real numbers. I feel like I should be able to do this regardless, though. For z2, really? Well, we're restricted to the region where, to the positive real region. Is that your concern? And also, like, this statement here was kind of like separate from, like, from what's on the right side, but like we're on this kind of like pizza slice domain, and I think that makes the bound true. Yes. They define this d theta domain. Have an essential singularity at infinity. Interesting. I know that e to the 1 over z had an essential singularity. Well, that might be at 0, though. I guess that would, well, yeah, that would make sense. If e to the 1 over z... Okay, yeah. Okay, yeah. Those are just the flip side of the same thing. Hmm. Think of that using Picard theorem, e to the minus e will take pretty much any arbitrary value near infinity. Yeah, I remember learning about that from the complex analysis book. Like, it takes every value infinitely often. I kind of think of it as like, except like 1, maybe. Oh, that's kind of funny. I think of it as similar to like sine of 1 over x near 0. Takes every value between -1 and 1 infinitely often. It's good intuition. Okay. Actually, yeah, considering that sine is built with ease, that's okay. Yeah, that actually that kind of connected some dots in my head, because sine of 1 over x is e to the I 1 over x minus e to the minus I 1 over x over 2i, right? Or something like that. Yeah. Like, if we want one for big O at infinity, the example they provide is right here. I know, I might need to give this one with e to the minus z a rest. I don't think it should be that hard, but I can't quite find the idea. I'm about to scroll away, so if you want to keep reading this example, take a screenshot of it or something. Similar analysis work for sine of z if we don't impose any domain restriction. Okay. Oh, interesting. Yeah. With e to z, it should be easier. Yeah, that's like where I got the example from, just like a few paragraphs after it, but they don't actually show the... They just claim this without proof. And I was trying to figure out what the proof is. Hey, Lucas. How's it going? I don't know. I was curious to read this paragraph again, because I read it once, but I didn't really get it, I don't think. If the set D is not explicitly referred to in a big O statement, it means the direction approach is not important or is understood by context. Oh, so you can make a big O statement about a direction of approach too? Huh. You have something in context, D can be taken to be an open neighborhood of the point Z equals Z naught or Z equals infinity. Z is understood from the context to lie in a particular set. They may not referring to the set D, we mean to admit all possible directions of approach within this set. In other words, D can be taken to be the intersection of a complex open neighborhood of Z naught with the set of interest. Z is real, D can be taken to be an open interval around Z naught. If Z is real and positive, but Z naught equals 0, D can be taken an open interval with left endpoint Z naught. Huh. They didn't choose an M in that example. It seems that M imposes what's inside the parentheses. Yeah, they didn't actually do the proof. That's why I was trying to like work it out. I don't... Maybe that's where... That's why I'm stuck. I should just choose an M. But I guess like if I made M like 1 is probably a good choice. Or you could, I mean, maybe even just do 10 just to be sure that you're good. You like how it looks like English, but it's math? Not really. That's what proofs are. Graduate math has a wall of text, or it looks like a Sudoku puzzle. Okay, if we just said the magnitude of z is greater than 10, what happens? We know e, the magnitude of e to the minus z, is bounded above by e to the minus 10. And what about 1 over z to the n? I don't know. A Sudoku puzzle has the least numbers in it. They said it's like Egyptian hieroglyphics found in a Chinese temple written by an Indian. You've never done a Sudoku? Oh, then those are fighting words when if Mbox heard those. Should learn about spectral sequence. YZ goes to infinity? Uh, that's just what they claimed. I guess. I don't know. You're crushing so many Sudokus these days? Noish? Do you think a number like x plus 1 over x to the x equals x can be interesting? It can be interesting. It's probably not. That's kind of the problem with math. Like you can assemble a lot of random arrangements of like numbers and variables, but proving it's interesting is the hard part. Sarah said that he accidentally turns algebraic topology from the 50-foot into a big game of Sudoku, or from the 50s. I read the apostrophe as feet, but no, I probably mean like the 50s, like as in years. That's funny. It's like the limit definition of E, but infinity times repeated. I guess you could maybe call it like that. Going through a bunch of old puzzles by Math Pesto on Logic Masters Germany. Ooh. Book PDF and page, please. Let me see if it's small enough for me to put it somewhere. Is this too big for Discord to handle? It does. It is. I think you got something, Ayush? Hit me with it. Oh my god, please. There. I don't know, it's just that numbers seem interesting since you also can find it using anything. Yeah, I mean, even just like pi, there's so many different ways you can represent that with different like series and things. And then the page, I guess I'll just type it in chat. Uh, book page 17. There we go. We convert z into polar form and theta is greater than pi over 2, or theta should be less than pi over 2, but yeah. This one of cosine or sine will be negative. Should make the exponent positive. Yeah, I had to do a lot of digging to find it. Yeah, there are other websites that I think Twitch doesn't appreciate if you say them, but they are out there. Oh wait, I mentioned in OpenGL, it's about like shading textures, anything related to graphics. It'd be cool to learn that, but I already have libraries in Python that are built for like plotting math stuff that work pretty well. So it'd be cool to learn that just for its own sake sometime, but it probably won't be anytime soon for me. So one of cosine or sine would be negative, which will make the exponent positive. I'm not sure why it would make the exponent positive, Ayush, or like which exponent you're talking about. Yes, it sounds good, Kyo. Feel free. Wait, okay, wait. See also exercise 1.5 below. Let me see exercise 1.5 below. I am getting like just kind of like mentally tired. So I wonder if I should just take a break, but if I can figure this out, it would be nice. This is basically the flip side where things we have positive exponents instead. So maybe this is a bit more subtle after seeing the hint. 1.3. Oh, you think about the result with the logarithms. Is almost pi over root 3? Really? That's kind of crazy. Graphics is way too fun, dangerous when you're in serious school. Yeah. Kyo linked a video about how easy it can be to use shaders to make cool art with code. And I'm not gonna lie, like it did kind of tempt me to like learn that. I don't have time to do it right now, but it was really cool. It's same up to 30. I mean, I wouldn't trust ChatGPT for that though. That's something you could easily find in Wolfram Alpha. For the first exponent was, after seeing your stream, it's way more subtle. Yeah, I might just let sleeping dogs lie. Because I think it's not that easy. You probably do need to rely on the result with logarithms. Because I'm not really finding it directly. Yeah, Lucas. ChatGPT is not your friend, even though it says it is. Okay, I think I might wrap things up here for the day. This feels like a good time for it. So that's what we'll do. Oh, okay, wait. Sorry, I usually literally just put something in chat. I mean, I'm not giving up. I'm just thinking about it for now. Like, I don't have any other ideas. I think I can do it. I just been doing math for 4 hours and 19 minutes. E to the... Okay, yeah. It's equal to 1 plus... Or 1 over e to the z cosine theta. What? You did some... I don't understand the math that you did there, Ayush. Oh no, I made it all stretchy. It's been so long since I've done that. There. So, Ayush, there's one step where I don't understand what you're doing. It's this step here that I'm about to write. This step right here seems incorrect. Like, how does this become multiplication here? And shouldn't this be e to the minus z? Well, you wrote an x there. If it's a plus, I think it's still wrong. Yeah, I'm sorry, Yusha. I'm really not seeing what you're saying there. But equality just... I can't make that work. Then you have to come up with something that gives... Yeah, Dessen. Thank you, Fembox. Ayush, I'm getting kind of done thinking for now, to be honest. I appreciate you trying, but I kind of want to take a break and go do something else for a while. If you're in the Discord, if you want, you can like post it there and I'll like get back to you eventually, but I want to wrap things up here. One over... I'm sorry, I think that's even more wrong than before. I'm not sure where you're getting that from. I'm sorry, maybe it's just my own misunderstanding, but that doesn't seem right either. I am going to cut the stream off here. Ayush, I appreciate you trying. And who's here on YouTube, thanks for being here. On Twitch, we'll look for a raid. So see you later.